Okay. Sorry, I forgot. Let me just do this really quick. 10 V's of big data, business data analytics, the requirements agenda, my company, software integration plus workflow automation, the overview, seek to understand what is big data. Big data, everything quantified and tracked. We're going to be talking about that. Advantages of big data, the 10 V's of big data, and understanding data risk for the purposes of testing. So again, all this is about, at the end of the day, being able to elicit and write requirements to enable testing. I mean, that's really fundamentally what the whole premise of requirements is about, is being able to write things that you can test at the end and validate that they actually pass. For those of you that are new, if this is your first session with us, you'll notice that there's a list of pictures on the right-hand side of the slide that represents the team of the future. Let me go ahead and just kind of go down the roles that you'll see. At the very top, you have what I call your business analyst product owner. Underneath that, I have my project manager, scrum master, DBA, database administrator. I'll be talking about that here in a second. Underneath that, I have your IT system architect. Underneath that, I have developer, data scientist, subject matter expert, one of those kind of roles. Underneath that, I have I have my QA tester. And then at the bottom, I have intelligent assistants. That's Cortana in blue. And it doesn't matter whether it's Cortana or Google Now or Siri or Alexa, the recognition that there will be some sort of assistant who will help you get your job done. They call it nudging. They're going to nudge you towards more productivity. So the whole mission of these series from the very get-go is to prepare you for the day that intelligent assistance is really fully a part of your work world. I mean, we have a lot of intelligent assistance as a part of our personal world, but this is really trying to prepare us for how do we elicit requirements and write requirements and test requirements for intelligent assistance. And that's really just a question of how do we do this for data, because data is the fundamental underlying mechanism that drives intelligence. Okay. That being said, so what is big data? So I saw this and I thought, okay, this really represents, it's everything. Every aspect of life, work, consumerism, entertainment, and play is now recognized as a source of digital information. I mean, everything. It's quantified, meaning storing everything somewhere, mostly in digital form, often as numbers. So last week, for those of you that were online, I talked about, when I teach a class, in particular, I always begin with the idea of how do you operate efficiently? And even though I waited till session 9 to bring it up, I usually start my classes with that concept, because I think people need to understand that as intelligent assistance becomes more of our daily working world or daily working life, it's going to force us to operate more efficiently, whether we like it or not. So the idea of how do you become efficient? And I tell everybody that the two most important words in my classes are the word operate, to recognize that everything, as an analyst and a project manager, you have to see things as systems which operate, and that those systems that operate generate telemetry, which is data that we use to measure everything. Great. So that's kind of what we're talking about here when we say quantified, storing everything, all the telemetry somewhere, mostly in digital form, often as numbers. Then finally tracked, quantifying and measuring everything continuously. And last week I brought up the fact that lesson number 1, the game is rigged against you when you don't realize you're in a game, and the game is called accounting. And eventually I'm going to talk about non-financial and financial accounting, which if you're a business analyst, that's the business side of being a business analyst. So we'll cover that later. All right. So what's big data as compared to, let's say, small data? I mean, and again, I know many people are literal when they watch these things, and it's just the nature of being an analyst. So don't take this slide literally, but just understand that I'm just trying to make a basic comparison. So for the V's that we're going to be talking about here in a moment, volume, velocity, variety, veracity, we'll kind of hit on those. So big data as opposed to small data. Big data is big. It's generally more than the human brain can comprehend in real time. As opposed to small data, it's a lot of data, but your brain can kind of wrap around it. You know, it's on the left-hand side, we're going to call it a data lake, and you'll see at the bottom nomenclature. And on the right-hand side, it's your databases, data warehouses, data marts. Velocity. Big data has gigantic waves of data every millisecond. And for those of you that are involved with the 5G rollout, you know exactly what I'm talking about. For those of you that are not, right now, the world is rolling out 5G. And as 5G becomes the de facto standard and our 4G phones go away, or we start to embrace 5G and it becomes the standard everywhere, the volume of data is just going to become astronomical. I mean, it's going to be amazing. As opposed to small data, steady stream throughout the data. Variety with big data, there's a lot of unknown file types. In small data, you have an expected set of file types. In big data, you have under veracity, you have almost no idea of how the data might come in or in what format, whereas in small data, you know where your changes might happen. The structure of big data is usually non-relational, as opposed to small data is relational. The hardware is generally data centers. I should have added an S, as opposed to file servers. The database for big data is generally NoSQL, not only SQL, as opposed to SQL. Processing on big data is tools like Spark or Hive or Pig, or there's a lot of new tools. This is a kind of an old slide. So as opposed to SQL, the query languages, Python, Java, R, SQL, as opposed to SQL. The areas of analysis are clusters for your data scientists, data marts, for your analytics, as opposed to just data marts. Optimization is done through predominantly in big data with machine learning. And with small data, usually it's manual, human powered. The people involved are fundamentally the same. The difference is now we have data scientists who are more actively involved in what we're doing. And finally, the nomenclature, the term data lake, just really represents our institutions are little islands of data. I mean, you could be working for the largest company in the United States of America, like Walmart, and it's a huge company, but within the worldwide lake of data, it's actually a little island of data. So the idea is that there's a lot of data, and it's going to be coming in at massive amounts. And as analysts, we need to be aware of this and understand this and be able to write requirements that are testable for dealing with all of these things. All right, so what are some of the advantages of big data? Why are we doing this? Well, basically this term today is the digital transformation, and 5G is ushering in the digital transformation through what's known as edge computing. And with the edge, you're going to have so much information available to you to allow you to make smarter decisions, design better products, give you deeper insights, hopefully give you greater knowledge, build optimal solutions, build more customer-centric products, and hopefully increase customer loyalty through more automated process, through more accurate predictive and prescriptive analytics, and ultimately better models of future behaviors and outcomes in business, government, security, science, healthcare, education, and more. There's no way to stop this train at all. If you don't like this train and you want to get off this train, then you might as well leave the industry because this is the train and it has left the station. And the idea is now you must climb aboard. So to kind of give you a tool, a takeaway, just really more buzzwords. That's really what I'm trying to get you to, is just to be comfortable with some of these buzzwords. And right now I've looked, you know, it started off, there was the 3 V's and then the 4 V's, then the 6 V's, and then I saw 7 V's and finally got to 10 V's. I was like, all right, we'll get to 10 V's of big data. So in no particular order: validity, variability, venue, vocabulary, vagueness, volume, velocity, variety, veracity, and value. Okay. I'm going to cover these in a little bit more detail here, but I just wanted to drop those buzzwords on you right up front. All right. Here, and I'm going to walk through them in an order, but again, nothing is locked in stone. So don't ever think that, you know, this is the way it has to be. It's just the way I researched it and put it together. But number one, the first and most important component of big data is value. How useful is the data? And some of the buzzwords that you're going to hear when you're talking to people about data value are, you know, hypotheticals. As the business analyst, especially if you go back to the very first presentation that I ever did, where I talked about the cross-industry standard process for data mining and machine learning, the CRISP DMML, which is very much similar or almost the same as the IIBA's certified business data analytics. Those two concepts are almost identical. In that arena, the business analyst is very closely tied to understanding business value, being able to be that representative to the team, you know, understanding the business, and starting with how useful is the data. So things that business analysts are going to be thinking about are hypotheticals, statistics or statistical events, and correlations. Then we get into more terms like, you know, volume, size of the data, and terminology, buzzwords like distributed data, tables, records, exabytes, petabytes, zettabytes. I mean, it's just going to get bigger and bigger and bigger. There's no end in sight to the amount of data that we're going to begin to accumulate. Velocity. This is the one that I think is really going to shock a lot of people, is just simply the data generation speed, because now almost everything will be in real time. So real time processes, streams of data that are just feeding in real time. Variety, data types. There's a lot of different terms: unstructured data, structured data, multi-factor, probabilistic, linked, dynamic. Again, these are all buzzwords that as an analyst, you want to start thinking about or doing some research on to prepare yourself for what is here now. I mean, it's not that it isn't here, it's here, it's just going through the deployment model. So as 5G deploys, all of these big data concepts will deploy as well. Data accuracy, data accuracy really asks the question about data accuracy. How accountable or trustworthy or authentic is the data? Then number 6, variability. It really asks the question, evolving behavior in the data source. So you're starting to see things where, you know, the data is changing data and changing models. Validity, data quality, again, asks about data quality, governance, and master data management, which really represents uniformity and accuracy and stewardship and semantic consistency throughout your data. Venue, multiple heterogeneous platforms. You know, today, we really have a lot of different sources of our data that all have to work together. So we have our internal ERP, we have our CRM systems, we might have connected to Facebook and LinkedIn and Twitter. And so the data is connecting and we're getting data from all these different sources. We might also have things like Dun & Bradstreet that brings in data and we use it to validate things. So again, these are all things that we have to be prepared to write requirements for testing. Vocabulary, data structure description. Now this is a term that I get into a lot of depth in my requirements class. I actually go into quite a bit of detail about the data dictionary and understanding data flows and data structure instances, as well as data element attributes. And we talk about data processes and data stores. And this is an area that I think is really important for not just the business analyst, but really an area that product managers, scrum masters, who for me are database administrators. That's a skill set that I see a good, strong scrum master or project manager having as we try to transition into this new world. And then lastly, vagueness, terminology confusion. You know, a few sessions back, we spoke about business rules and I talked about semantic communities and taxonomy, as well as business rules. And so all of these V's are really questions that need to be answered as you begin to write testable requirements for data, which brings me to the last slide, which is understanding data risks for testing. And, you know, as analysts, as we write requirements and or test cases, things that we have to be aware of. All of those V's affect, there's a lot of things that can go wrong. Data integration complexity, for one, is a challenge. Data security, privacy, and governance, another challenge. The lack of metadata and schema for big data, that kind of directly correlates to the data dictionary, or the lack of having a master data dictionary that allows you to manage all of this in relation to your business rules. Poor data quality is always something that we have to be thinking about when we're writing requirements, testable requirements. Noisy data that is probably corrupted, dirty data that's inaccurate, misplaced data values, inexact values, insufficient data size, poor representation in the data sample, and redundant data. So these are all things that you need to be thinking about. So in summary, this is Train the Trainer. And my hope is that at the end of each of these sessions, you will have picked up some small piece of information that you can share with everybody else. All of the information is open source. As I always explain to people, I didn't invent it, I just explain it. So my mission is to simplify things so that you can get work done faster. It's very complex stuff. I mean, and that's the reason I love doing this, is because it's literally, I was joking about it, it's like the Pacific Ocean of information. It's both broad and deep and goes in lots of different directions. So I can never run out of topics. That's what I think is so fun about this, teaching all these or doing these sessions. So I have an unlimited number of topics to present. It's going forward. As long as you guys keep showing up, I'll keep presenting them. So we just covered what is big data. Everything quantified and tracked. We talked about the advantages of big data. We talked about the 10 V's of big data and understanding data risks for writing test cases, or understanding the idea of being able to write requirements that are testable. So with that, that's kind of the end. I'll take any questions if you have it. If there's any questions, feel free. Have you got any questions? That was a pretty fast one. Well, if you're new to this and we are not connected on LinkedIn, please, let's stay in contact with each other. Please connect to me on LinkedIn. If you need to directly connect with me, just send me an email, or you can text me, or, call me, text me. Find me here on meetup.com, Tampa Bay IIBA. Connect with me on LinkedIn, or if you want further information about my courses, please you can schedule a Zoom meeting through meetings.hubspot.com, anything like that. What training do you recommend for these items to educate yourself more? Which items are you talking about? Data? Are you talking about, I recommend my training. I know that was kind of self-serving, but I mean, what specifically are you looking for? Are you looking about data? Are you looking about requirements? Are you looking about which, Joanna, can you be a little bit more specific? Big data items. So right now, there's not really any particular, I could be wrong on this, but I haven't found anything that is industry standard yet on these kinds of items. But you know what's a great source, believe it or not, is a great source that I read a lot, is the Azure blog from Microsoft. I always tell people, whether you love Microsoft or don't like Microsoft, you should pay attention to Microsoft, because they have their fingers in every single pie that's imaginable. And they do a really good job of explaining things for people that are very busy, for executives and things of that nature. But there's a lot of information out in the marketplace. But there's that, you can look it up. It's Azure blog, AZURE, from Microsoft. And then there's another great site if you're interested. It's called KD Nuggets. If you look up KD Nuggets, it's a great site on data science. And then I'm trying to think if there's another one. There's another one that I like that comes out of India. There's some really great websites that are out of India that have a lot of great information. But if you go to KD Nuggets, if you look up KD Nuggets, you'll get a lot of really good. It's a great starting point for data science. And then that'll lead you to more information about data, big data. Anything else? Any other questions? All right. Well, then thank you guys so much for your time. And hopefully I'll see you again next week. We're going to get in and talk about the 5 steps to automation. So I'm going to go through categorize, organize, document, integrate, and automate, and actually walk you through what it means to truly be automated as opposed to computerized. For those of you who were here last week when I talked about, people think they're automated because they have a computer. I'm like, no, they're just computerized. So we're going to actually talk about what is how to actually be automated. So, all right. Well, thank you all again for your time, and have a great weekend. And I will talk to you all next week.